Hey everybody, it's Dynamic Math, and today we're going to take a peek at what it means for any two angles to be classified as congruent angles. Hopefully you've answered the question or questions that appear in this applet or worksheet here, but we'll taking a look here. Again, any of these applets, you could take any big points, you can move them around. Okay, you can alter the positions of the angles if you wish. You could change the size of the angle itself by messing with the green slider, right? So again, let's just go ahead and I'm going to set mine there. You set yours wherever you would like prior to beginning. And let's actually slide the black slide me slider and see what happens. Here we go. Check it out. 1, 2, and done. Now that informally illustrates these two green angles are congruent. Well, let's just try this again here for a second. Let me see. Maybe I'll move this here a little bit, and let's make this angle like acute, okay, and do whatever. So there we go, and we'll slide the slider one more time. Notice we have a translation by a vector and rotation about a point. Just like congruent segments, remember segments were congruent if and only if you can map one onto the other using one or a composition of two or more isometries. Remember what an isometry is. That's a key point here in geometry. An isometry is a transformation that preserves distance, or in this case, it's preserving the size of that angle. Now, technically, this green item you see here is actually a sector of a circle. It's actually not an angle. It's a sector. But regardless, just it goes to help illustrate that the size of the angle really right in here, right? That angle size is not really changing as I translate or actually slide that angle along, slide the sector along. So a translation does not change size, nor does a rotation about a point. So that green sector is congruent to this green sector that it came from right over here. And that's what's logically implying these two angles are congruent. Again, any two angles are congruent if and only, just like for the same reason two segments are congruent. Congruent segments and congruent angles technically have the same definition. In fact, any two items in geometry are considered congruent items using the same definition of congruence, which we will establish here. That any two items are congruent if and only if any one item can be mapped perfectly onto the other using one or a composition of two or more isometries. Isometries are transformations in the plane that preserve distance, and in this case they preserve size. So technically here we had a translation about a vector and a rotation about a point. So the fact that congruent angles have equal measures is not the definition. The fact that if angles are congruent, yes, their measures are equal, but that's the effect of the angles being congruent. That's not the cause. What's the underlying cause? The underlying cause of angles being congruent is the fact that I could take one and map it perfectly onto the other using any one or composition of two or more isometries. Thanks for watching.